Good afternoon. As I promised you, the way that we're going to try to do this class going forward, since we have people meeting on Monday and then people meeting on Wednesday, and we're covering usually about two chapters per week. So I was thinking to myself that if I do the recording of the first chapter and then present that to the second class and then do the recording of the second chapter, present that to the first class, and even though they're a little bit out of order, everybody gets the benefit of both chapters lecture. Okay, so this is kind of a show and tell, as you can imagine. What we're trying to do here is we're trying to develop means for showing the future value of multiple cash flows. And this is a very pertinent chapter because when we have a project for a company, typically the cash flows are going to be uneven. And there are going to be multiple ones of them. And when I say they're uneven, when you have a new piece of equipment that you're buying, for example, then you're going to have an initial cash outlay and some inflows, we assume, because you're not going to buy the piece of equipment unless it's going to generate some cash inflows for you. But in the first year, of course, you have the outflow, and you may have that over several years, depending upon the nature of the investment. But if you have the all of the cash outflow in the first year, and then you have different streams of inflows over time, then these are the kind of problems that these real world problems are the kind that we need to actually look at and address. So here's a good one to start with. You think you are able to deposit $4,000 at the end of each of the next 3 years in a bank account paying 8% interest. So notice the wording there, at the end of each of the next 3 years. You currently have $7,000 in the bank. How much will you have in 3 years and how much will you have in 4 years? Well, there are several little problems that have to be uh, calculated here. And so let's just take a look at the first one. Um, currently have $7,000 in the account. So let's jump over to an Excel spreadsheet because I'd rather do it there than walk you through the math manually. It's just easier to do. So let's go up here and click the FX and find the future value. And they tell us that the rate is 8%. And they tell us that the number of periods, because we have the money in the account now, this $7,000 is already in the account. So we have the $7,000 for 3 periods, and the present value of it is 7,000. And so when we do that calculation, you see that that $7,000 in the bank today at 8% interest is going to yield 8,817.98. Now, they treat it because of the way that the Excel program works. They treat that as a cash outflow, and basically it is. You took the money from someplace and put it into an investment account of some sort. Okay, so that takes care of the $7,000 that we had initially. Now, the second thing that they tell us is that we have a $4,000 amount that we're going to put in at the end of each year. So that means that you don't have benefit of that interest on the $4,000 in year one. You only have it at year two and you're at the end of year three. So we want to go calculate future value again on that. And um, let's take a look. The same interest rate applies, 0.08. The number of periods is going to be 2 in this case, and the present value is 4,000. And so the end of the first year, you put in $4,000, and at the end of 3 years, that 4,000 is worth 4,665.60. And we'll go back and we'll check this against the PowerPoint to make sure that it's correct. But um, this following this routine, I think, is going to get you the correct answer. All right, so we look at the next $4,000 one. So we have an 8% interest again. This time we only have benefit from year 2 to year 3, and the present value of that investment is $4,000. And so $4,320 is going to be the yield of that $4,000 put in at the end of year 2 through the end of year 3. And now, in addition to that, at the end of year 3, we're going to put in $4,000, but that $4,000 doesn't need to be calculated because it's already at present value. Um, and so we just put in that $4,000. And those 3 items, or 4 items, I should say, are going to give you the amount of the investment's worth at the end of 3 years. So we'll just do a quick auto sum on that. 21,803.58 is the value of that investment at the end of 3 years. But they also ask us what is the value of it at the end of the 4th year. Well, we've already calculated all of these guys, so we can take this number and apply it to the formula for future value. And so in this case, we're going to get 8% on the investment. We have 1 period, okay, from year 3 to year 4. And the present values, I'm just going to click on this guy over here because that's the current present value. And 23,547.87 is the present value of the future value, I should say, of that particular investment. So I can pop back over here and take a look at this. And you see that, oops, got to go to the next slide. We look at 23,547.87, 21,803.58 are the 2 numbers that we were looking to arrive at. And again, going back over, you can see that we in fact did arrive at 21,803.58 and 23,547.87. So I'm going to get rid of those because we're going to create some new problems here. And so we'll go to the next one. And it says, suppose you invest $500 in a mutual fund today and $600 in 1 year. And so if the fund pays 9% annually, how much will you have at the end of 2 years? And so what's happening to you is that you're going to start out with a $500 investment. And so let's pop back over to our Excel sheet again, and we're going to do the same kind of thing. We're going to do a future value calculation here. The rate is 0.09. Remember that that if you're doing periods, you have to account for every single period, but they're only doing these in terms of simple interest, so you don't have to worry about any compounding that's occurring at interim periods here. In this case, we're going to have that investment, that $500 investment for 2 years. Okay, year 1 through year 2, and put in the 500, and so that is valued at 594.05. Now, at the beginning of the next year, you're going to put in a $600 investment, and again, using future value, the rate's going to be 0.09. We have, in this case, 1 period to deal with, and a present value, in this case, of $600. And so, okay. And so when we add these 2 numbers together, we have 1248.05. Remember again, these are going to represent ultimately cash inflows for us, but because we treated these were outflows when we put them in there, we put the 500 in, then we put the 600 in. Because they were outflows there, they're going to show up as negative numbers in the calculation, 1248.05 and 1248.05. So we know that we've done the calculations correctly in that one as well. Okay, let's pop over here and see what's next. How much will you have in 5 years if you make no further deposits? Oh shoot, I wish I hadn't changed that, but I'm going to just put it back in at 1248.05. That's the amount that the present value at the end of 2 years. And so what do I want to do now? I want to see what the future value is at the end of 5 years. So there are a couple of ways I could do it. I could go back and I could take each one of those things, the 500, and look at it over 5 years. I could take the other one and look at it over 4 years and like that. But it's much easier just to say, well, This is at the end of 2 years. So what's the future value of that at the end of another three? So 0.09 would be your interest rate. You have three more periods in which to deal with this. Present value then is equal to this guy right here. And when we do that, we come up with 16, 16, 30. And there's a little bit of a difference here. And I'm not sure that I know why it is though. It's a little bit of a difference because when I put that number in, I didn't put it in with all of its decimal points. I just put it in as 0.05. But if you were to look at that number um, by extending the decimals, you'd see that it was probably um, 0.0537 something, like that. So you're going to wind up with a little bit of a difference in terms of your total. And I suppose maybe I can even get this to do it here. Yeah, there you go. 13, 16, 16, 26, which is, I think, exactly what you come up with over here, 16, 16, 26. That's just by, the other one was just rounded off, and that's the reason that that looks like that. Okay, so that takes care of that problem as well. All right, let's take a look at another one and see what we have. Suppose you plan to deposit $100 into an account in 1 year. Now you have to really watch the wording here. Suppose you plan to deposit $100 into an account in 1 year. So you didn't do it today. You're going to do it a year from today. 300 into the account in 3 years. How much will be in the account in 5 years if the interest rate is 8%? Okay, so back over here again. We're going to look at the future value, in this case, of $100 at, I forgot the interest rate, 8%. Is that what it was? Yeah, at 8%. The future value at 8%, and only for 4 years because you're not putting it in until next year. Okay, and we're looking at $100 present value at the end of that year. And so that's the yield of that one. Wait a minute here, did I put that in right? Yeah, I guess I put it in right. Okay. All right, and then in 3 years, you're going to put in another 300. So again, looking at the future value here, in this case 0.08, the number of periods is only going to be 2 because you'll put it in 3 years, so that means you only have 4 and 5 left in which to draw interest. The present value in that case is $300 when you put it in. And so now when we add those two numbers together, 485.97, let's see if that's what they came up with, 485.97. Okay, so that is how you do future value when you have multiple cash flows. This one you could find the present value, and this says the present value. So this is a different question because notice now that we're talking about present value instead of future value. All right, so they kind of switched gears on us there. And so let's just take a look. You have to find the present value of each cash flow and add them. Okay, so what we have here is they've got 4 years that they're giving us at 12%, and so the cash flow 200, 400, 600, and 800. So let's pop back over to our Excel spreadsheet again and switch gears to the present value side. And so the first one was 200, so let's just pop this in. Look at present value now. The rate is 12%, so 0.12, and for 1 year. And the present value of 200. And so there's the amount for the first year. The next year is going to be 400 is just going up by 200 in 200 increments. So let's look at it again. And here we say, okay, the rate is 0.12. The number of periods this time will be 3 periods because we're looking at this thing over a 4-year investment period. And here we put in 400. And so that's the present value of that particular one. Now we're going to go to 600 for 2 periods. And the rate is 0.12. 2 periods. Future value 600. And okay. And then finally we have the present value, in this case, of 0.12, 4 periods, and future value of 800. And boom. And so now let's add these up and see what we get. 1450.01. Oops, what did we do? 200, 400, 600, 800. What did I do? I zigged when I should have zagged someplace. 78.57. Did I say 2 periods? Oh, I said 2 periods, not. I said 3 periods, not 2. I'm sorry. So that and 318 and 427. I must do the same thing here. I got them reversed. Yeah, 3 periods here, 600, and 4 periods. So that should be right now. 1432.93. Yeah, sorry about that. I did a little dyslexia on my on the screen there for you. Yeah, that's what dyslexia looks like. So you've got a medical situation that you got to look at as well as the actual calculation. All right, so that gets us there, and this is on present value now, not on future value. All right, let's see what they want us to do next here. All right, another example. You are considering an investment that will pay you $1,000 in 1 year, 2,000 in 2 years, and 3,000 in 3 years. So if you want to earn 10% of money, how much would you be willing to pay for it today? Okay. So now let's just take a look at each one of those and see what the present value is, and we'll just go through it the same way. Only this time we'll try to do it correctly. All right, so present value again, and the rate is 10%. The number of periods is 1 because you want it to pay you within 1 period. You want to pay $1,000 within 1 period. So that's the present value of that investment today, okay? And so the next year you want it to pay you 2,000. So again, let's take a look at it. Same way, present value, and the rate is 0.0. In this case, we have 2 periods, and the future value in this case was 2,000. And so there's the result for that. And then in the third year, you want to be able to pull out 3,000. So remember, what you're trying to do is what kind of an investment do I have to be able to put in today in order to be able to pull out those amounts in those periods of time. So here's the rate again of 0.10. In this case, we have 3 as the number of periods and $3,000 as the amount. And so when we add those all together, if we've done it correctly, 4815.93 4815.92. So there's a penny difference, and I'm not quite sure why that is, but I'm not going to worry about it. So, um, so you can see now that in order to be able to pull out $1,000 at the end of year one, 2,000 at the end of year two, and 3,000 at the end of year three, in order for you to be able to do that, you're going to have to put in $4,815.93 today. Okay, so that's what that's telling you. All right, let's go back over here and see if they've got any others for us here. Now they're talking about using the calculator. We don't use calculators in this class. We don't have any. So I'm going to skip that portion because I can't demonstrate it anyway. And pop over here to annuities and perpetuities. And so an annuity is a finite series of equal payments that occur at regular intervals. So for instance, you have an annuity that pays you $20,000 over a 5-year period. So that's an annuity. And if it's an ordinary annuity, it comes due, the first payment comes due at the end of the year and at the end of the first period. And if it's an annuity due, it comes at the beginning of the period. That's all that the difference means there. And again, they're wanting to show you on the calculator, and I don't know why they did this because they actually have they actually do this a different way. Um, on the spreadsheet, of course, and this one said that they were going to show you the formulas, didn't say anything about calculators, so not quite sure why they did it this way. All right, so after carefully going over your budget, you have determined you can afford to pay $632 per month toward a new sports car. You call up your local bank and find out the going rate is 1% per month for 48 months. How much can you borrow? Determine how much you can borrow. We need to calculate the present value of $632 a month at 48 months at 1% per month. Now, up until this point, what we've been doing is we've been looking at this in terms of 1-year increments. So now what we're talking about is a monthly compounding. So in that case, you're going to have to put in 1%, or you could put in 0.12 divided by 12. It doesn't matter either way. But you've got 48 periods, so you have to put the 48 periods in there, and the 632 is the future value. I'll let you do that one on your own and see if you can come up with the right number. Let's look at this next one, which I think is more interesting because it's a lot like it's a lot like the real world. And suppose you win the Publishers Clearinghouse $10 million sweepstakes. The money is paid in equal annual installments of $333,333.33 over 30 years. If the appropriate discount rate is 5%, how much is the sweepstakes actually worth today? And this is kind of a lesson in real life is what it is. So when you start thinking about, oh, I'm going to win $10 million in the sweepstakes, how much is it actually worth? So let's pop over here to our spreadsheet again and just kind of get rid of this. We don't need it anymore. And now what we're going to do is we're going to look at the present value of essentially what it amounts to an annuity, because it's going to pay you over 30 years at $333,000 a year. So your interest rate is 5%. We have a 30-year term, and the payment that they're going to make, notice that we're not going down here to future value. This is now the payment that they're going to make. And that's the payment they're going to make. And therefore, the actual amount that this $10 million is worth over that 30-year period is going to be $5,124,150. And of course, now they're still making, if you think about it, if I put in equal to 333 times 30 periods. Well, rounded, that's $10 million. Okay, because that 33 is, of course, a repeating decimal, but you actually get, they're actually going to pay you in terms of actual dollars, they're going to pay you 10 million. However, they're not considering, over that 30-year period the effect of interest, okay, or the time value of money. Now, the same thing could be true when you're thinking of if you were to take that same thing and turn it around to future value, okay, and look at it from the perspective of future value, what you would see is that that $10 million only has a future value at 5% over 30 years of $5 million. And that's why if you win the lottery or the publisher's clearinghouse, and they give you a choice and say, well, do you want the money over in increments, or do you want the money paid out in one lump sum? Then what you discover is that if you want it in one lump sum, you're going to get a much discounted amount of money. Okay, so we went about 26 minutes here, which is pretty good for not having a break. And I think it's probably about as much as you want to go in one of these kind of things anyway, because they're so labor intensive, or I shouldn't say labor intensive, but they are that too. But they're so digitally intensive when you load them up that it takes a long time for them to load and so forth to YouTube. But that's where I'm going to call it for the day. And if you can look at any other things that you need to do along the way.